All right, today for geometry, we have 2.7. We're going to do proofs using some angles. So our objectives are to state and prove that angle congruence is an equivalence relation, prove and apply some theorems involving congruent adjacent angles, and prove and apply theorems involving linear pairs and vertical, supplementary, complementary, and right angles. So we have lots of definitions today. To start us off. So first up, an old definition from page 26 is congruent angles. So those are just angles with congruent measures. That's it. So then we just have another reminder. Angles are congruent when they have equal measures. Okay, so measures we're looking at. So just like in the last section in 2.6, we talked about looking at the object, like the segment, and then the measure. Those are two different things. Okay, so angles are congruent. So we would say like angle A is congruent to angle B when A is equal to B. Or we would say the measure of angle A is equal to the measure, put a little m, of angle B. So, pardon me, let's go back. Angle A is congruent to angle B when the measure of angle A equals the measure of angle B. That's going to be important for you to write down. Remember, angles are congruent when their measures are equal. Okay. So theorem 2.7.1, angle congruence is an equivalence relation. Then we have an adjacent angle sum theorem. So 2.72, that theorem. If each of two adjacent angles is congruent to another angle in a second pair of adjacent angles, then the larger angles formed are congruent. Okay, so let's look at this. What this is saying is we have these two angles, two sets kind of angles, right? Adjacent angle sum theorem. So if each of two adjacent angles is congruent to another angle in the second pair of adjacent angles. So we're given angle 1 is congruent, okay, that's what that little mark is, to angle 3. Okay, we're also given that angle 2, so it has 2 marks, is congruent to angle 4. Okay, we want to prove that angle ABC, okay, so that big giant angle in there is congruent to angle PQR, so this giant angle. And that's what it's saying. If each of the two adjacent angles, adjacent means side by side, so if each of these is congruent to each of these, then the larger angles formed, so that larger angle that's formed by those two adjacent angles, are also congruent. Okay, so we're given this adjacent angle sum theorem. Awesome. Next up, we have the adjacent angle portion theorem. So this one is saying if two angles, one in each of two pairs of adjacent angles, are congruent, and the larger angles formed are also congruent, then the other two angles are congruent. So this one's kind of the flip of that. Okay, so it's saying if angle 1 and angle 3, so one of the small angles, are congruent, and the larger angles, so angle ABC, is congruent to the other larger angle, PQR, then we can know that angle 2 is congruent to angle 4. Okay, that's what this theorem, the adjacent angle portion theorem, is saying. So if you have a portion of them that's congruent and the big angles are congruent, then the other one is too. All right, then we have some classifications for angle pairs. Okay, so first up we have a linear pair. So a linear pair is a pair of adjacent angles. Okay, so they're adjacent and they make a straight line. So angle 1 and angle 2 are adjacent. Okay, they're not congruent, they're just adjacent. They're touching. The thing about them is they make a straight line. Okay, vertical angles. So vertical angles are a pair of non-adjacent angles formed by two intersecting lines. Okay, so angle 3 and angle 5 are vertical. So 3 and 5 are vertical. I understand that they're side by side, but they are called vertical angles. They are opposite of each other is how we would look at it. So angle 4 is vertical to angle 6. Okay, so it's like one's on top, one bottom, side by side, but they're opposite of each other. Complementary angles, then, are two angles that have a sum of 90 degrees. Okay, so 38 plus 52 equals 90 degrees. Those are complementary. Just any two angles that have a sum of 90 degrees. The last one down there is two angles with the sum of 180 degrees. I'm going to not move that down yet because these two linear angles, or a linear pair, also are supplementary. These are also supplementary angles because if I added angle 1 and angle 2, I'd get 180 degrees because they're linear. They make a straight line. A straight line is 180 degrees. Okay. So that last one, though, to look at it, supplementary angles, two angles with a sum of 180. So again, here, if we look 128 plus 52, that's going to equal 180 degrees. So they're supplementary. You will use those, all of these, a lot this year. We're building lots of vocabulary this year. All right. Recall what you can and cannot assume about figures. Okay, when you are looking at figures, things that you can and cannot assume. Okay, so you can assume that x, y, and v are collinear. Okay, so if we're looking here, x, y, and v, they're on the same line. You can assume that. You can also assume betweenness, right? That u, v, and w. V is between w. Doesn't mean it's equal in there, it's just between them. You can assume that angle 8 and 9 are vertical angles. You can assume that 7 and 8 are linear pairs. They make a straight line. Okay, you can assume that 7 and 9 are linear. That 7 and this angle over here are vertical. So several things. What you cannot assume is that UW is perpendicular to XY. So this symbol right there, that means perpendicular. You should know that perpendicular is a 90-degree angle. You cannot assume that. You can also not assume that UV is congruent to VW. You can never assume that the measures are equal. If the values are given, okay, if values are given, use them regardless of the appearance. So oftentimes, especially in mine, your drawings, or you might find a note that say drawings are not to scale. That's an L, not a T. Drawings are not to scale. So even if it says something is 15 and it looks like maybe it's only 12, it doesn't matter. If the value is given, use it. Okay, some more vocabulary. The linear pair theorem. Angles that form a linear pair are supplementary. Hey, I just told you that earlier, but there's an actual theorem for that, the linear pair theorem. Okay, theorem 2.7.5. Okay, so the ones that have a name are generally more important, but all of them will be helpful. If two angles are adjacent and supplementary, then they form a linear pair. So this is how you can prove them a linear pair. You could like list two out and say they're a linear pair. If they're adjacent, so they're side by side, and they equal 180 degrees, then you can say they're linear. Okay, vertical angle theorem. You're going to want to know this one really well. Vertical angles are congruent. Okay, vertical angles are congruent. That means that angle 9 is congruent to angle 8. And that means angle 7 is congruent to this unlabeled angle over here. Okay, because vertical angles are congruent. We now know that and can use that. All right, then we have a whole list of theorems there. So supplements of congruent angles are congruent. Okay, so if we have supplementary angles, okay, if we have supplements, so if I have okay, and I say, oh, these are congruent. So the supplements of congruent angles are congruent. So that means that these angles would be congruent with each other. Complements of congruent angles are congruent. All right angles are congruent. Okay, that makes sense, right? Because all right angles are 90 degrees. 90 equals 90 equals 90. Congruent supplementary angles are right triangles. So there we go. If we have congruent supplementary angles, and we say, oh, hey, this one's congruent to this one, we can say, oh, well, then this is 90, and this is 90. Okay? If one angle of a linear pair is a right angle, then the other is also a right angle. So we've got this linear pair. Okay, if I say this one is 90, well, by golly, that means this one is 92. Okay, it's just not labeled. But that's that theorem that it's telling you that. Okay, then we're also going to talk about some corollaries. Okay, a corollary is a statement that follows almost immediately from another theorem. Okay, so this one is a corollary. We had supplements of congruent angles are congruent. So the corollary is supplements of the same angle are congruent. So it just almost follows immediately from another theorem. All right, some helpful strategies for proofs. Diagrams are going to be very helpful for you. Applying definitions and previously proved theorems. Okay, so you're going to want to keep track of all your definitions that we've talked about and old theorems. Using similar proofs. Okay, your homework is going to be so helpful, okay, for you to keep your homework organized as well, like your notes, because you're doing proofs and notes. We're doing them in your homework as well. They will be very helpful to use as examples. Reasoning or working backward from your conclusion. We talked about that before. It is wonderful to work backward. That's not a problem. Now, the other thing is there will become a time where we're proving the converse. Okay, so if we're proving the converse, we're going to try reversing the reasoning done in a previous proof, but we'll get there. All right, so there were no examples in the book for these. We just have, so I pulled out a couple exercises just so we can kind of use some of these theorems to help you do some stuff. Okay, so we're going to look at exercise 22 first. We're going to use the figure to find the value. Okay, to find each value. So we want to find the value of A, the measure of angle MON, and the measure of angle NOP. All right, so first up, to find Y. Well, we have a Y in this angle and a Y in this angle. Okay, but what do we know? Okay, so we need to use this inductive and deductive reasoning. What do we know about these two angles, about angle MON and NOP? Well, they're linear, right? So we have linear angles. What do we know about linear angles? All right, linear angles are a straight line. Okay, what do we know about straight lines? Straight lines are 180 degrees. All right, perfect. So what do I need to do with these two things to get 180 degrees? I would add them. So I would take that quantity, 3y plus 7, and add it to my other angle, 9y plus 5, and set that equal to 180 degrees. I can combine my like terms. 3y plus 9y is 12y, plus 7 plus 5 is 12. That equals 180. Start balancing. I'm going to subtract. So 12y is going to equal 168. Divide by 12. So y equals 14. Hopefully you have, you show some work. Your work doesn't take up as much room as mine does. All right, then I need to find the measure of angle MON. Well, once I do that, like that's easy since I found y. So MON is going to be 3y plus 7, right, is the measure of angle MON. So I'm just going to go 3 times 14 plus 7. 3 times 14 is what? What is 3 times 14? Is that 42? Yeah. All right, 42 plus 7. So 49 equals the measure of angle MON. Let me put it degrees. 49 degrees is the angle, is the measure of angle MON. And now to do the measure of angle NOP, well, NOP is this angle, so that's the 9y, or 9 times 14 plus 5 equals the measure of angle NOP. So 9 times 14 is going to be what? 126 plus 5, so that is 131 degrees equals the measure of angle NOP. Okay, but again, we have to ask ourselves, what do we know? And where does that take us? Okay, because these are like treasure maps. It's like you're here, there's your destination. You have to get to your destination. Okay. All right, let me erase that and we'll move on to 24. Again, exercise 24. Okay, not an example. So use the figure to find each value. So here we're looking for the measure of angle W, and then the measure of angle QRT. So QRT is equal to that W minus 16 degrees. And the measure of angle TRS, which is equal to 2 times the quantity W minus 18. All right, so what do we think about here? Well, we have these three angles that make up this straight line, right? We have this, let me use a different color. That green doesn't show up very good on the black. We have three angles that make up a straight line. We've got three angles. What do we know about straight lines? Straight lines are 180 degrees. So we're just going to add all three of these angles together, right? We're going to have W plus, because that's this angle, the quantity W minus 16, plus our last one, 2 times the quantity W minus 18, all equals 180 when we add them together. All right, so we got to solve our equation. So we have, I'm going to go ahead and combine some like terms, but I'm going to have to distribute too. So like W and W is going to be 2W minus 16 plus 2W minus 2 times 18 is 36 equals 180. All right, now I can combine some more like terms. 2W plus 2W is going to give me 4W. Negative 16 minus 36 is going to give me negative 52. All right, then I'm going to add, let me switch up my colors here. I'm going to add 52 to both sides. So 4W equals 180 plus 52 is what? Good, 232. I'm going to divide by 4 to get that W equals 58 degrees. All right, so my W equals 58 degrees. But again, I had to draw some conclusions and use some reasoning to get there. All right, now I want the measure of angle QRT. So QRT. So the measure of angle QRT is going to equal W minus 16. W is 58. So that's 58 minus 16, which should be 42 degrees. Okay. And next I want the measure of angle TRS. So that one's going to equal 2 times the quantity 58 minus 18. Okay, you don't have to distribute once you know these numbers in here, right? You could say, oh, this is 2 times 58 minus 18 is 40. 2 times 40 is 80 degrees. All right, so that's what we're going to use some of those theorems that we've learned about angles and linear pairs, vertical angles, supplementary angles, complementary angles, okay, to be able to look at problems and draw some conclusions so we can do the math behind them. All right, we'll see you later. Have a good one.